Okay, so here's your introduction to circuits. So any circuit has some basic components. You have a power source, which in this case is just a 9-volt battery. And basically the purpose of the battery is to give energy to the electrons. So they come in, they're depleted of energy, they come out, they have energy, and they're flowing out. So in this situation, part of this is just getting the terminology and how it physically looks. So on the program you're going to use on the FET simulation, these are always nice and they're at right angles. And you know, it's clean and you don't have to worry about connections gone bad. But in reality, pay attention, Bruce. So in reality, the circuits are just kind of a little bit messy. So in this situation, I've got what's called a knife switch, okay? So when I close that, you'll notice that I've got a red LED light and a blue LED light. And within this, I've got the battery. And so the electrons are flowing through, and we'll get into the direction that they flow later on. And so the electrons are flowing through, it's going through like this, then it's coming through this. Now, this is what's known as an ammeter. Now, ammeters, there's two types of ammeters. So this is what's called like a contact ammeter. So when you physically hook up an ammeter, this is measuring how much current, and current is measured in coulombs per second. So right now, we're at about 0.5 amps. So that means we got about 0.5 coulombs per second flowing through this circuit. Now, what's important about the ammeter is that it's hooked up in what we call in series. It's an integral part of the circuit. So if I disconnect the ammeter, notice that the circuit goes out because it's hooked up in series. So if I connect that back up, that completes the circuit. Because what it's doing is that it's measuring those electrons as they're flowing through there. So unless it's called a non-contact ammeter, which is what you're going to see on one of the FET simulations, ammeters are always hooked up in series. They have to be an integral part of the circuit. Now, the other thing that you can measure is voltage. So there's two primary things that you measure on a circuit. Current, which is measured in amps, which is shown by the letter I. And then you have voltage, okay? Remember that's joules per coulomb. Now, voltmeters work differently. When you talk about voltage, you talk about a voltage across something. So within this circuit, I've got a resistor, okay, which is this little thing right here. And all resistors are coded with different colors. And there's a schematic that tells you what type of resistor that is. So resistors are measured in ohms, OHMs, shown by the Greek letter, looks like a horseshoe, okay? So resistors act like a door in a hallway. So they provide a certain amount of resistance, hence the name, to energy that's flowing through there. So what I can do is I can measure the energy drop or the voltage across an object. So when you're talking about voltage, you talk about voltage drop. So what I'm going to do, I'm going to take this, I'm going to touch this on one side over here, and then I'll touch it on the other side. Now, when I did that, the voltmeter went down below. So all I have to do is switch these up. I'll just touch the opposite sides, okay? So when I do this, okay, and I get that voltage, so that voltage is about 4.5. So I would say I've got a 4.5 volt drop across my resistor. Now I can do the same thing with this LED bulb. So I can come over here, and that's at about 4 volts. So I can measure the voltage drop across the LED bulb. I can measure the voltage drop across the red one, and that's at about 3.5. Or I can also measure the voltage drop across the battery itself. So the voltage drop across the battery is about 8 volts. So it's a 9-volt battery. There's some internal resistance. So there's that voltage drop. So what's happening is that those electrons, as they're flowing through, the light bulb, the resistor, the other LED, that's using up that energy. So when they get back to the battery, they're depleted of that energy. The battery then, through a chemical reaction, takes those electrons, gives them energy, and sends them back out. So it's kind of like a cafeteria where you get your energy boost. So right now, there's a couple of key components that you need to look at through the camera. So if I disconnect the blue LED light, okay? Now, we're going to focus on the red one. If I disconnect the blue LED light, okay, what you'll notice is that the red LED light stays on because this blue light is hooked up in parallel. So that energy, those electrons come here and they hit a point. So right now, without this external circuit in parallel, all of that energy continues to flow through here. Now, if I hook that up, okay, then now there's an external way for that current to flow. So if things are hooked up in parallel, if you disconnect one part of it, the rest of the circuit remains intact. Now, the red light is in series. If I disconnect the red light, notice that the blue light also goes out because what I've done is I've stopped that current flowing through this part of it so it can't get over there to the LED light. So if I hook that back up, okay, and we're flowing. Now, if I disconnect that blue light, an interesting thing happens. So, and this is going to be huge later on. When I disconnected that blue light, my current went down, okay? When I hook it back up, my current goes back up. So you can make the analogy of how your mom cooks, okay? So if your mom cooks in parallel, then this is like your brother came home from college and didn't leave because of, the coronavirus. So right now, your mom is feeding both of you. She's feeding you, okay, the red light, and she's feeding your sibling the blue light. So because of the fact that she's got to produce more food to feed both of you, that current goes up. So if your mom cooks in parallel, when you add more and more siblings to the circuit in parallel, the amount of current goes up. This is what happens in your house when you run too many things on the same circuit. Your breakers will throw because your breakers down in your basement are probably rated about 10 to 15 amps. So as you put more and more things in parallel, that increases the current. Then the breaker throws, you got to go down and reset it. So there's your household wiring tip. So your house is wired in parallel because if your house was wired in series, if you had one bulb go out, all the bulbs in your house would go out. So this is why you wire your house in parallel and not in series. Okay, so that's just kind of an introduction to them. We're going to use a FET simulation to do a lot of this, but I kind of wanted you to physically see how this plays out. We'll talk more about capacitors, but here's what I want you to realize. You have things that are in series, okay, they're all hooked up like this, or you can have things that are in parallel, which they're like an external loop. So you have series, remember this, your ammeter is hooked up in series, your voltmeter is hooked up in parallel, and your voltmeter measures the voltage drop across a portion of the circuit, or you could measure the voltage drop across the whole thing. Okay, so there you go.